Last episode, you gave every parameter its own learning rate. RMSProp watched how big each gradient tends to be and shrank the noisy ones, grew the quiet ones. That fixed the scale problem, but it threw away something we loved 2 episodes ago: momentum, the memory of which way we were already heading. Adam's whole pitch is why choose? Keep momentum's direction, keep RMS props per parameter scale, run both at once, and then deal with the one bug that combo creates. On step 1, both running averages start at 0, so they lie to you. Today, we watch Adam catch its own lie and correct it. Here's the mental model people get wrong first. They hear Adam is adaptive and picture some clever controller that decides a learning rate. It doesn't decide anything. Adam keeps two simple running averages per parameter. One, call it M, is the average gradient, the direction smoothed. The other, call it V, is the average squared gradient, how big the swings have been. The update is just M divided by the square root of V, direction over volatility. That's the entire idea, and there's no controller, just two leaky buckets and a division. Let's fill the first bucket. M is exponential momentum, exactly like episode 7. Each step, M decays to 90% of itself and adds 10% of the new gradient. M augurs 0.9 Mano plus 0.1 G. The misconception here is that M jumps straight to the gradient. It doesn't, it eases in. With our toy gradient of 1.0 on this weight, step 1 gives M the 0.1, 1.0, 0.10, not 1.0, a tenth. The bucket is mostly empty because it started empty. Second bucket, same trick on the squared gradient. V 0.999 V plus 0.1 G squared. Notice the decay is 0.999, far slower than M's 0.9. That's deliberate. The scale estimate should be steadier than the direction. Step 1 with G on or 1.0 gives V 0.001, 1.0, 0.001, a thousandth. And here's the trap that bites everyone. People expect V to roughly equal G squared, which is 1. Instead, it's 0.001. Both buckets are starting cold, way below the true values. And that's the bug we have to fix. Watch what happens if we don't fix it. The naive update is M over root V, 0.10 divided by the square root of 0.001. Root of a thousandth is about 0.0316, so 0.10, 0.0316, 3.16. With learning rate 3/10 thousandths, the step is tiny, but the ratio is wildly inflated, 3.16 instead of the 1-ish it should settle to. The cold start makes early steps point in a believable direction, but with a distorted magnitude. The first step is exactly when you can least afford a distorted magnitude. Here's the fix, and it's almost insultingly simple. We know M is biased low by a factor of 1, 0.990. That's the geometric series math of an average that started at 0. On step 1, that factor is 1, 0.9 or 0.10, so we divide M by 0.10 to undo the bias. M or 0.10, 0.10, 1.00. The corrected momentum is 1.0, exactly the gradient, which is what an honest one-step average should be. The misconception is that bias correction is some deep statistical magic. It's division by a known shrinkage factor. That's it. Same correction for V with its own decay. V on our V POC was 1, 0.999. Step 1, 1, 0.999, 0.001, so V or 0.001, 0.001 over 1.0. Now look at the corrected update. M over root V is 1.0, 1.0, 1.00. Clean, the magnitude you actually wanted. Multiply by the learning rate, 3/10 thousandths, and the real first step is 0.003. Compare. Corrected M is 0.1000, uncorrected was 0.0100. A tenfold difference on the term that matters most early. The bias fix isn't a rounding tweak. On step 1, it's a 10x rescue. And the beautiful part, the fix fades. By step 10, 0.9 on 10 is about 0.35, so the correction factor 1, 0.35 is 0.65, a gentle nudge. By step 50, the factor is essentially 1, and bias correction does nothing at all. It's training wheels that quietly fall off. People assume Adam carries this overhead forever. It doesn't. It matters intensely for maybe the first dozen steps. Then it's free. That's why we use the canonical learning rate, 3/10,000ths, and the standard betas 0.9 and 0.999. Those are the numbers Adam was tuned around. Open o9 adam.py. It's one optimizer class and a 5-step loop on a single weight, so you can read every number in the table we just walked. No net, no batches, just G, the 2 buckets, the 2 corrections, and the step. The whole point is that the figure is this file's actual printed output. Top of the file, the hyperparameters copied from the Bible so they don't drift. LR0304, beta 1 0.9, beta 2 0.999, EPS 1A8. These 4 lines are the entire personality of Adam. The comment notes that LR34 is the good default, the one we've been calling LR all course. The state M 0.0, V 0.0, T 0. Both averages start at exactly 0. That's not laziness, it's the standard initialization, and it's why we need bias correction at all. If we'd warm started these, there'd be no cold start lie to fix. The step function, line by line. Increment T, update M with the beta 1 mix. Update V with the beta 2 mix on G squared. So far this is just momentum and RMSProp stacked, no correction yet. This is the naive Adam a lot of people stop at. The 2 correction lines, the heart of the episode, M hat, M os 1, beta 1, and V hat, V, 1 of beta 2t. On T1, the denominators are 0.1 and 0.001, the exact shrink factors from the concept scenes. These 2 divisions are the entire difference between broken early Adam and the Adam everyone actually ships. The update and return. W demand R's LRM hat, SQRT V hat, plus APIS. The APIS lives outside the square root. That's the Adam convention, not inside. Getting that wrong is a real and common bug. We return DW plus the 4 intermediate values, so the loop can print the full table. The driver loop, a constant gradient G or 1.0 fed in 5 times. Real gradients aren't constant, of course. We hold it fixed on purpose, so you can see the buckets and the corrections evolve without the gradient itself muddying the picture. Each iteration prints 1 row of the figure. Run it and you get 5 rows. Step 1's corrected M of 1.0 towering over the uncorrected 0.01. The gap shrinking every row until they nearly touch. That's Adam in one table, momentum, RMSProp, and the little division that saves the cold start. Next episode we stop looking at one weight in isolation. Same problem, 4 optimizers, SGD, momentum, RMSProp, and Adam. Racing on the same loss, the showdown.